genetic shuffling. But the Y chromosome is different. It doesn't get reordered every generation. Instead, it passes unchanged from father to son. And so do its markers, creating a perfect genetic trail for me to follow. But of course, men don't travel alone, and the journey of man is the journey of everyone. Somewhere here, 50,000 years after his journey, I hope to find the marker of the ancestral grandfather of the Aborigines. It feels good to be out in the field. Every sample you take, you can't help but wonder whether this guy will be the one. But the next stop is the lab. There, it's death or glory. You thought I'd hung up my lab coat? Well, so did I.
We've managed to collect several hundred blood samples from around the Maturai region. It's taken us days and days and days of work. And now we've got them in the laboratory, we've got a huge amount of work still to do. It's not just about collecting the sample, because we have to go through a purification procedure before we can get to the DNA and find this marker we're looking for. The first step involves getting rid of the red blood cells, the things that you might think of when you imagine blood, the stuff that carries the oxygen around your body. Then we get rid of the rest of the proteins, and we get down to a solution which is quite pure. We're ready for the last step, getting the DNA out of that. We want to add something to dehydrate the DNA molecules. So we add isopropyl alcohol. With any luck, we will see the DNA come out of solution. Looks a little bit like cotton at this stage. And there it is. I love this stage. I've done it thousands of times, and yet it still amazes me every time it happens. And it really is the essence of what we're looking at. This molecule is a historical document. At the final stage, down inside the solution, and snag the DNA, and lift it out. Voila. Pure DNA. And there we go. And ready to move on to the next step.
We store the DNA samples in a refrigerator to preserve them. So far, so good. Now we have to analyze this stuff. It's a 2-hour process. Then we've got another 300 samples to go.
We are going upstairs to the sequencing machine to load the samples on. And the idea behind this machine is that it's a bit like a sieve, a molecular sieve. And it's going to separate the sequencing reaction products on the basis of their size, their length. And by reading up a ladder of these, we can actually tell what the DNA sequence is, the sequence of letters in the code, A, C, G, G, T, and so on. Quite a high-tech machine, pretty exciting piece of kit. And it's right down here in this room. Power back up, because if the sequencer stops in the middle of a run, you're going to lose all your data. So you have to make sure you have power the whole time. And it's in here, in this room, protected from the environment. And here we are, the sequencing machine, that molecular sieve. Now the sieve bit is actually a chemical matrix that's inside of this tiny little tube, less than 1 millimeter in diameter inside. This is what the DNA is going to be forced into via an electrical charge from one end of the sieve to the other. We've got the data from hundreds of samples on the computer here, and now my job for the rest of the day and maybe into tomorrow is to go through each one of these sequences looking for the tiny difference that distinguishes the coastal marker, the thing that leads us to Australia. So it's going to take quite a while, a bit tedious. Sometimes I wish I'd done something other than science.
If the marker's here, it'll give itself away as a tiny spelling mistake in just one of the 4 letters that spell out the story of our past. ACGT. I'm searching for just one accidental change in a sequence that's 6 billion long. From C to T. Is that it? Yes, a misprint of just one letter, but just enough, hopefully, to change history. I've got some really exciting news.
Oh, good.
Let's take a look at it. I'll show you.
If you look at this particular position, see that change
Yes.
from C to T?
T, yes.
That's the marker.
We've done it. This tiny spelling mistake occurred around 2,000 generations ago. It proves that our African ancestors did pass through here on their way to Australia. In the end, one man from a small village west of Madurai had the answer. It had been passed down to him from the very first humans to set foot in India. And here he is. One microscopic change rewrites the history of an entire continent. And that feels pretty awesome.
Fantastic. We should really celebrate.
In this case, the genetics is really leading the way because there is no archaeological evidence for a human presence in India until 30 or 35,000 years ago. It's amazing for me to think that as I look out on the subcontinent of India, that people are carrying this signpost in their DNA.
From Africa to Australia, and now, for the first time, the missing link we found in India. The genetic evidence of modern man's first coastal migration to Australia. Most of the route would have been pretty easy, requiring the same beachcombing survival skills learned in Africa. But there was one final obstacle. Even at the height of the Ice Age, the coastline didn't quite reach to Australia. There were still 150 miles of open ocean. Whether by accident or by design, they made it. A pivotal moment in our history. The quantum leap in our thinking strikes again. Modern man's ability to imagine a world beyond his horizons had taken him to the other side of the world.
Although we have no direct evidence for the methods used by these coastal migrants to reach Australia, reach it they did by around 50,000 years ago. And we have a clear genetic trail leading out of Africa along the entire route. But that only accounts for around 10% of the world's population. The other 90% took a different route, and that's where we're headed next.
The descendants of this second wave of explorers would become Europeans, Asians, and